In the following video lecture, we're going to discuss the very basic idea of a hydrogen oxygen fuel cell. A hydrogen oxygen fuel cell, or any cell for that matter, is a device that converts chemical energy to electrical energy. So its basic purpose is to produce electricity, which could be used to do or produce work. Now this over here is a basic diagram of a hydrogen oxygen fuel cell. There are two inputs to this fuel cell. In one input you have hydrogen gas coming in, and this hydrogen gas is going to act as your fuel in this fuel cell. From the other side, from this other entrance, there is oxygen gas, which is generally basically air that is pumped through this, because air contains oxygen, and this would be your other input. Air is being pumped into this fuel cell. Then you have these electrodes over here, the ones that I'm going to shade right now. These are your electrodes, and these electrodes are generally made from costly platinum. Platinum. The reason why platinum electrodes are used is because platinum is a very good catalyst as well. So it's also going to activate the whole process and speed up the whole process, lowers the activation energy. So platinum is acting as an electrode for transferring of electrons or current, but it's also being used to activate or lower the activation energy and speed up the whole reaction or the whole process. This middle part over here is a polymer that that contains an electrolyte. So it's a polymer which contains an electrolyte. Remember, an electrolyte is a solution that contains ions. So the first type of fuel cell that I'm going to talk about is where the electrolyte contains OH ions. So it could be an alkali, it could be NaOH, or it could be KOH in aqueous state. So this middle part, this polymer over here, contains an electrolyte, and ions, if they are needed or if they are produced, they would be produced in this electrolyte, and they would help in completing the circuit and in current flow. Now the first reaction that happens at this side, on the left hand side, where hydrogen gas comes in and it gets into contact with the OH ions which are present in this electrolyte. So remember, I told you previously that the electrolyte, this polymer over here, contains a lot of OH ions. So it's probably a solution of NaOH or KOH aqueous. Hydrogen comes into contact with those OH ions and it reacts with those OH ions. And when it reacts with those OH ions, it ends up producing a water molecule. And to balance this equation, there would be two water molecules, and there would be two OH ions. And as a result, electrons are going to be produced. Specifically, there would be two electrons that would be produced at the electrode, at the platinum electrode over here. All the reaction, because platinum is acting as a catalyst as well, so the hydrogen gas over here and the OH ions are basically reacting over the platinum electrode. And when these electrons are produced, this platinum electrode has a lot of electrons being produced on it when this reaction happens, and this electrode gets negatively charged as the reaction proceeds. Meanwhile, on the other side, on the right hand side, when this oxygen comes into contact with this platinum electrode, what it does is that the oxygen reacts with the water molecules that are present in the electrolyte. Remember, it's an aqueous solution, so there would be a lot of water molecules over here as well. So on this electrode, on the right hand platinum electrode, and again, platinum is activating the whole process as well. It's reducing the activation energy, it's helping the reaction as well. So oxygen over here comes into contact with water molecules in this electrode over here, and they end up reacting, and oxygen reacts with two water molecules, ends up gaining 4 electrons to produce 4 OH-1 ions. Now, as you can see on the right hand side, electrons are being gained. So if electrons are being gained, this metallic platinum would lose electrons, and it would start getting a positive charge on it, because all the electrons are being consumed by the OH ions, by the oxygen over here. Oxygen and water molecules are gaining electrons to produce OH ions. So if electrons are being gained by oxygen and water, this platinum electrode would get positively charged because it would lose electrons. Now, if you look at both the electrodes now, one electrode is getting negatively charged, electrons are being produced on this electrode, and the other electrode is getting positively charged. So if you connect an external circuit, then let's say this one is your voltmeter. If you connect an external circuit, electrons would flow from the negative potential to the positive potential. So there would be a net flow of electrons because electrons are going to get attracted to this positive. So if there's a circuit, these electrons would start flowing, and this voltmeter would register potential difference because this side would have a negative potential. It would be negatively charged, and the right hand side would be positively charged, and the voltmeter is going to show a reading. And if you put any load over here, this current is going to drive that load. So current is produced in this way. And the output of this left hand side, as you can see, hydrogen gas was coming in, reacting with OH minus 1, and it was producing 2 water molecules. So the output over here, the waste that would be produced would be 2 water molecules. On the other side, there would be no waste produced because the oxygen would be reacting with water to produce 4 OH ions that would become part of the electrolyte. So only the unused waste gases or unused air would be the output over here. Remember, there is oxygen in the form of air coming in, so the unused oxygen or air would be coming out as a waste product. So one good thing about this entire electrochemical cell or hydrogen oxygen fuel cell is that water is your only byproduct that is produced, so it's basically pollution free. Another thing that you need to note as well is that if you look at the right hand electrode reaction, you will notice that OH ions are being produced. So over here OH ions are being produced, which means that this electrode, or the reaction that's happening on this electrode, on the right hand electrode, OH ions are being produced, which means that there would be a net production of OH ions, and the electrolyte would be gaining OH ions. So OH ions would be produced on this electrode, and the quantity of OH ions in the electrolyte would increase. But if you look at the left hand electrode, you would notice that OH ions are being consumed on the left hand electrode. So if OH ions are being consumed on the left hand electrode, which means that this left hand electrode over here would be gaining OH ions for the reaction. So these OH ions would be consumed. So there would be a net flow of OH ions across the electrolyte. This electrode would be producing OH ions, whereas the left hand electrode would be gaining OH ions. So there would be a net flow of OH ions from right to left within the electrolyte. I will also try to write an overall equation for this hydrogen oxygen fuel cell. For that, what I'm going to do is I have two equations, two reactions happening, one at the right hand electrode and the other one at the left hand electrode. What I'm going to do is I'm going to try and add the two reactions. So first I'm going to write both reactions on top of each other. So on the right hand side there's O2 plus 2H2O plus 4 electrons, and it's producing 4 OH minus 1. And on my left hand electrode, the reaction that's happening is it's H2 plus 2 OH minus 1, and it's 2 H2O plus, it's producing 2 electrons. Now before adding the two equations, I need to make the electrons that are being gained and the electrons that are being lost equal. Remember, whenever there is a redox equation, make sure to balance the number of electrons that are lost and the number of electrons that are gained. For that, I would need to multiply this equation by 2. And then I'm going to add the two equations. So over here there's O2, then I have 2H2, then I have 2 water molecules. Below I have 4 OH minus 1s because it's being multiplied by 2. Then I have plus 4 electrons. So I've added the left hand side. On my right hand side I have 4 OH minus 1 in the top equation. Then in the bottom equation I have 4H2O multiplying it by 2. And then I have 4 electrons. Now I'm going to try and simplify this overall equation that I've written. These 4 electrons are going to get cancelled out. Similarly, 2 water molecules on this side and 4 water molecules on that side, they're going to get cancelled out. There would only be 2 water molecules left. 4 OH minus 1 ions would also get cancelled out. Now if I write the overall equation again, it's going to be O2 plus 2H2, and my product is going to have just 2 water molecules. So this is my overall reaction that's happening in this hydrogen oxygen fuel cell. There's only water that's being produced, and this is what we discussed earlier as well, because on the right hand side there's only unused gases coming out, but on this side hydrogen is reacting with the OH ions in the electrolyte to produce 2 water molecules. So these are the 2 water molecules. These are the only byproduct of this reaction. Now one thing I need to clarify for O levels is that if you're studying in O levels, you don't need to go into a lot of detail for a hydrogen oxygen fuel cell. What you need to know is that there are 2 reactions happening. One is happening at the right hand electrode, where oxygen is coming in contact with water, and it's gaining electrons to produce 4 OH minus. So there's a reaction going on where electrons are being gained, and on the other side there's another reaction going on where electrons are being lost or produced. So over here electrons are produced. So you don't need to go into the detail of how this reaction is derived. Just remember this, that there's a reaction that gains electron on one side of the electrode, and there's another reaction going on the left hand electrode which ends up producing electrons. So this electrode over here produces electrons, and the other side ends up gaining electrons. So these are your 2 reactions that you need to remember when you're discussing the hydrogen oxygen fuel cell. One other important thing is whenever you're giving an exam and a question comes on the hydrogen oxygen fuel cell, they always ask you about the advantages of using a hydrogen oxygen fuel cell. And one of the advantages that we have already discussed is that it's pollution free, because water is the only byproduct. So there's no problem with the production of carbon dioxide. There's no carbon dioxide being produced. There's no global warming issues. Water is the only byproduct, so it's a very pollution free fuel. The other very important advantage of using a hydrogen oxygen fuel cell is that it's a renewable energy source. The raw materials that are used, hydrogen, can be obtained from water, and oxygen is easily available from air. Now so far we have not yet developed any efficient methods of actually getting hydrogen from water, which makes the whole process slightly expensive, but it is still a renewable energy source. So in the future it could replace fossil fuels that have a limited availability. Then when you're discussing advantages, you also always get a question about disadvantages of using hydrogen oxygen fuel cell. One disadvantage is that it is expensive, because we've already discussed that we haven't yet developed any cheap or convenient method of obtaining hydrogen, so which makes the fuel that we are using in the fuel cell very expensive. So this entire process is expensive so far, but in the future we might hope to bring down the cost. But right now it's very expensive, which is why it's not frequently used. You're using hydrogen oxygen fuel cells in spaceships and in planetary exploration, but it's very expensive. The other difficulty about the hydrogen oxygen fuel cell is that it's difficult to store gases, because your fuel is a gas. Liquid fuels can be easily stored. They don't need to be compressed. But when you're storing gases, you need to compress them, because gases occupy a large volume. So you need to compress the gases, which takes them to higher pressure, and there are chances of explosions. It's not going to be safe to store gases. Liquids can, on the other hand, be easily stored, like petrol, etc. So that's another disadvantage of using a hydrogen oxygen fuel cell.